Hello everyone, in this video we are going to discuss about Chemical Engineering GATE 2019 Fluid Mechanics questions with solution. GATE 2019 question paper and answer key link is available in my description box. You can download it. Question number 28. An incompressible Newtonian fluid flows in a pipe of diameter d1 at a volumetric flow rate capital Q. Fluid with same properties flows in another pipe of diameter d2. d2 is equal to half of d1 at the same flow rate capital Q. q1 is equal to q2 is equal to capital Q. The transition length required for achieving fully developed flow is L1 for the tube of diameter capital D1, while it is L2 for the tube of diameter D2. Assuming steady laminar flow in both cases. Objective of this problem to determine the ratio of L1 to L2. Okay. So we have four options. Answer for this problem is option B. I am going to explain how is it. Data. So incompressible Newtonian fluid. Incompressible means density is a constant. So we have two pipes. Pipe 1 diameter is a D1. Transition length is a L1. So flow rate is a capital Q. So for pipe 2 length is a L2. Diameter is a D2. Volumetric flow rate is a capital Q. So the Q values are both cases are same. Q1 is equal to Q2 is equal to capital Q. Okay. So the both sections are same. Assume steady laminar flow in both cases. Objective of this problem, so to determine the ratio of L1 to L2. So next solution part, transition length for laminar and turbulent flow. So here assumption is a laminar flow, is right? So the length of the entrance region of the tube necessary for the boundary layer to reach the center of the tube. And for fully developed flow to be established, this is called as a transition length. Am I correct? So the velocity varies not only with the length of the tube but also with radial distance from the center of the tube. So flow in the entrance region is two-dimensional. So what is a fully developed flow? Unchanged velocity distribution is called as a fully developed flow. So our assumption is a steady laminar flow. So the transition length for laminar flow, so the formula x t divided by capital D is equal to 0.05 into Reynolds number. Okay, 0.05 into Reynolds number. So where xt is equal to transition length, capital D is a diameter of the pipe. Okay, Re is a Reynolds number. So here L by D is equal to 0.05 times of Re. Okay, xt is equal to L, D is a D, 0.05 into Reynolds number. So rearrange this expression. L is equal to 0.05 D into Re. Why I am using here capital L? So the transition length L1 and L2 is given in our problem. Okay, that's why we should take transition length is equal to capital L. But formula is xt by D is equal to 0.05 times of Re. xt is equal to L. Okay, xt also transition length. So we have two pipes, right? So for pipe 1, L1 is equal to 0.05 into D1 Re1. This is equation number 1. So for pipe 2, L2 is equal to 0.05 into D2 into Re2. So this is equation 2 is right. So here we have two expression. So equation 1 and equation 2. So divide these two expression. So L1 by L2 is equal to 0.05 into D1 Re1 by 0.05 into D2 Re2. So the common terms are cancelled here. So 0.05, 0.05 are cancelled. Finally we get d1 into RE1 divided by d2 into RE2. This is equation number 3. So we know the Reynolds number is right. Reynolds number is equal to rho Vd by mu. So here L1 by L2 is equal to, already we have d1 by d2 is right. So into RE1 by RE2. So RE1 mean rho V1 d1 by mu divided by RE2 rho V2 d2 by mu is right. So density and viscosity, so both pipes are same is right. The fluid is a incompressible fluid. So we should take density as a constant, viscosity also the same viscosity value. Why? Because the fluid is a same fluid. So here L1 by L2 is equal to d1 by d2. So the common terms are cancelled is right. The rows are cancelled, mu's are cancelled. Finally we get V1 d1 by V2 d2. This is equation number 4. So we know the formula volumetric flow rate. So in our problem, so for pipe 1 and pipe 2 volumetric flow rates are same is right. Q1 is equal to Q2 is equal to capital Q. So the Q formula, area into velocity. This is volumetric flow rate. So from that V is equal to capital Q by A. So this is the velocity formula. So in our equation, take the fourth equation here, L1 by L2 is equal to, so here d1 by d2. This is the same d1 by d2. So here replace the V1. What is the V1? V1 is equal to, here that is equal to the Q1 and Q2 both are same is right. So we should take capital Q. Capital Q divided by, so the first pipe area is A1. Okay. So here replace the V1, Q by A1 is right. This is the V1 term is right. So then V2. So similarly V2 value, V2 is equal to second pipe flow rate also the same values right. So here the Q divided by the second pipe area values are A2 value. Okay. So they replace the V2, instead of that substitute capital Q by A2. Okay. So here Q is a denominator, A2 is a numerator part. Why? Because the V2 is a denominator part is right. So they replace V1 and V2. So the V1 Q by A1, V2 Q by A2. So the substitute all this term here. Which one is a cancel here? Q's are cancel. Finally we get d1 by d2 whole square. So the numerator d1 into d1 is there. Denominator d2 into d2 is there. d1 by d2 whole square. Rest of the term a2 by a1. So here what is the a2 and a1 value? This is a pipe area. So pipe area, generally area is equal to pi d squared by 4. So the a1 is equal to pi d1 squared divided by 4 is right. So this is the area value is right. Pi d1 squared by 4. Similarly a2 values are pi d2 squared by 4 is right. So here substitute a1 and a2 value. So the a2 value, so here a2 is equal to pi into d2 squared divided by 4. Okay. So this is the value of a2. So they replace the a1 and a2 value here. Find out the L1 by L2 value. Pi d2 squared by 4 here is right. So d1 by d2 whole squared into a2 value pi d2 squared by 4. a1 value pi d1 squared by 4. So common terms are cancelled is right. Pi's are cancelled. 4's are cancelled. So finally we get d2 square divided by d1 square. Already we have d1 by d2 whole square. So here numerator d1 squared into d2 squared by denominator d2 squared into d1 square. So d1 squares are cancelled. d2 squares are cancelled. Finally we get L1 by L2 is equal to 1. This is the answer. Okay. So already I said answer for this problem is option B is right. This is the correct answer. L1 by L2 is equal to 1. For further related videos, you can like, share and subscribe my channel. Thank you.